are the criteria which define the static stability of the vessel. And we also know that whether it is GM, where kg is required, km minus kg minus FSC, or GZ, km minus kg sine theta. So whether it is GM or GZ, kg is required for both of them. Now, how have you been calculating the kg? You have all been calculating the kg since you joined pre-C. How have you been calculating? You are given an initial condition of displacement and kg. Then you are given what are the changes made. You allow for the changes to get the final kg. Am I right, guys? Correct?
Yes, sir.
This is how you. Okay, so the kg which you were given in the question at the beginning, where did that kg come from? That would have come from applying the previous operations to some other kg. How did the previous one came? Like this. When did it all start? Okay, you were born to your parents were born to their parents were born to their parents. But when did the first human being come from? Where did the first human being land from? So where did the first kg come from, guys? The first kg of the ship is obtained through inclining experiment, and that is obviously the light ship kg that we are interested in. So the objective of the inclining experiment is to obtain the kg of the light ship. That is the objective of the inclining experiment. Am I clear? Right? Okay. What are the requirements of inclining experiment? Is it necessary that should I do? Is it required by law? Should it be witnessed by surveyor? Well, guys, if you determine or if a ship owner with malintentions misrepresents or calculates the light ship favorably, which may not be correct, then it could endanger the ship, the cargo, and the lives on board. Therefore, the inclining experiment is required to be conducted on all ships which are passenger ships, irrespective of their length, and cargo ships of 24 meters or upwards. And why should they be inclined? To the Code of Intact Stability says to determine the elements of stability. But what is that element? That is the kg. So when you read this line, that means there are no exceptions. Yes, to everything there are exceptions. This is by and large every passenger ship, regardless of its size, and every cargo ship of 24 meters or more in length must be inclined when it is complete or nearly complete, so that the elements of stability, that is the kg, can be determined. But of course, there are some exceptions. The administration may allow the inclining test of an individual ship to be dispensed with, provided basic stability data are available from the inclining test of a sister ship, and it is shown to the satisfaction of the administration that reliable stability information of the ship that is being exempted can be obtained from the data of the previous one. So guys, what is it trying to say? Suppose there is a ship, suppose there is a yard which is making series of sister ships, and a ship has been inclined, and other ships are going to be more or less on the same line. Then, if the administration of the flag state of the ship accepts, they can say, okay, you need not incline this one, we'll use the results of the previous one. But guys, when they may be called as sister ships, but do you mean sister ships are exactly same in displacement LCG? No. So to be able to avail this dispensation, or to be able to grant this dispensation for administration, also there are tolerance levels. Not because just something is called as a sister ship, you exempt. After all, if there are two twins, and you want to say, okay, yeah, we can stitch the clothes of the second one based on the measurement of the first one, then what does it mean? That means their measurement should be nearly equal. If one is a 5-footer, other is a 7-footer, even though they are twins, how can you base the measurement of the first, base the measurement of the second one based on the first one? No. But if one guy is 5 feet 5 inches, other is 5 feet 6 inches, probably yes, what you're saying, if the builds are similar. So to dispense with even the sister ship, the administration has a tolerance limits. And what are they? To be dispensed from an inclining experiment, the deviation of the light ship mass between which ships, the ship which has been inclined, whose data you want to use, and the ship in question. If the length is less than 50 meters, the difference in their light displacement shall not be greater than 2% of the light ship mass of the lead ship. Which one is the lead ship? Lead ship is the ship which has already been inclined, whose data is being used. If the length is greater than 160, sorry, this tolerance limit comes down to 1%. And if the length is anything between 50 to 160, then you have to determine by linear interpolation with between 1% and 2%. Have you understood this? What am I trying to say? Or you have any questions to ask, guys? Let me know. Is it clear? If there are sister ships and you are seeking dispensation from exemption from inclining, then the lead ship and the ship in question, their light ship displacement should fall within this tolerance, these tolerance limits. Is that clear, beta?
Yes. Yes, sir. Sir.
Yeah. Yeah.
सर आप इसका सर आप थ्योरी का नोट्स भेजोगे आप हमें?
नहीं, अभी डिस्कस हो रहा है तो क्या थ्योरी पढ़ोगे? तो परसों 4 दिन बाद तुम्हारा एग्जाम है, तुम थ्योरी पढ़ते रह जाओगे समीर। समझाने का फायदा क्या होगा? अगर थ्योरी के नोट्स भेजने हैं तो आई कैन डू अवे विद द क्लासेस एंड सेंड यू द नोट्स बेटा।
नहीं, पढ़ने के लिए, एग्जाम के टाइम पढ़ने के लिए।
अबे इसके बाद पढ़ने का टाइम कहाँ है तुम्हारे पास? समझो अच्छी तरह से।
हाँ सर, ठीक है।
हाँ, और चाहिए तो स्क्रीनशॉट ले लो, तेरे जो अच्छा लगे तो स्क्रीनशॉट ले ले, ठीक है बेटा?
ओके सर, ओके सर।
Whatever you want to take the screenshot, no issues. Who's stopping you?
Okay, sir.
Guys, is it the displacement only which is to be considered? No, also the LCG of the two ships. Guys, the idea of doing it in the last now is you should not waste time before your exams. You should just do it here and you should be able to write and handle these. The deviation of the light ship's LCG referred to its length should not be greater than 0.5% of the light ship of the lead ship. So that means the difference in their longitudinal center of gravities should not be greater than 0.5% of the length of the lead ship. So only when these two conditions are within the tolerance levels, then the administration may exempt a ship from inclining and may use the result of its lead ship to evaluate the stability of the new ship. Is that clear, beta? Am I clear?
Yes, sir.
Okay. Now, the administration may allow the inclining test of an individual ship or class of ships to especially designed and carriage of liquids or ore in bulk to be dispensed with when referencing to existing data of similar ship clearly indicates that due to ship's proportions and arrangements, more than sufficient metacentric height will be available in all probable loading conditions. Now, guys, why is administration getting into it? Administration is getting into it because on kg, the stability and the survivability of the ship depends. That's why administration is getting in. But guys, those of you who have sailed in tankers, did you ever see your chief mate calculating the GM of the ship? No. Why? Because on tankers, GM is never an issue. Why is GM never an issue? Because unlike cargo ship where you may have lighter cargo in the hold and heavier cargo on deck, and kg may be very high, in tankers, you have to start loading from down below. Yes or no, beta? You can't start loading higher up and leave the space down below empty or something. Am I right, guys? Yes or no?
Yes.
Yes. So for tankers, GM is never a concern. Likewise, if your ship is loading ore is very heavy. Then if ore is very heavy, kg will always be very low. So GM will be more than enough all the time. So why was administration poking its nose? Administration was poking its nose because they want to ensure safety. But for certain types of ships like tankers and ore carriers, if GM is not a concern, then why should administration bother itself? They'll say, okay, you calculate the kg whichever way you want. We know your ship will still have enough stability. So in that case, and guys, it's always may. It is not must. It is always may allow. The administration may allow. Administration may exempt. It is not your birthright that you will fight for exemption or from the inclining experiment. Is this point understood, guys? If anybody has not understood, let me know. Whichever point you have not understood, the idea of explaining each point is you should know there should not be need to do anything more than this now, guys. Now, guys, when should the ship be re-inclined? Okay, when the ship is newly built, you have determined the kg. But what happens if you carry out a lot of structural changes in the ship? Then the center of gravity can again shift. So where alterations are made on a ship so as to materially affect the stability of the ship should be re-inclined. So that applies to both passenger and cargo ships. But for passenger ships, because there are a lot of lives on board, there is one more requirement. Like you have so many surveys, load line survey, this survey, that survey. On passenger ships, there is also something called as light displacement or light ship survey. At what frequency? Every 5 years. And if the light ship determined during the survey changes from the light ship that was earlier, or the LCG of the light ship during the survey is found to have changed by more than the tolerance limit, then passenger ship should be re-inclined. So for passenger ship, the light ship survey report, which will be every 5 years, can also drive the need to re-incline the vessel. Okay, but if there's a material change, then of course you can always re-incline. For passenger ships, at periodic intervals not exceeding 5 years, a lightweight survey should be carried out on all passenger ships to verify any changes in the light ship displacement and its LCG. And if it is found that the light displacement of a passenger ship during the passenger ship survey changes by more than 2% of its changes by more than 2% of its earlier light ship displacement, or its LCG has shifted by more than 1% of the length, then the passenger ship should be re-inclined. So what is the need? Now, if the question says, what is the requirement for re-inclining? Number one, whenever there is a major structural alteration, which is likely to materially shift the center of gravity, the vessel should be re-inclined. Okay. But for additionally for passenger ships, at every 5 years interval, there has to be a light ship survey. And if the light displacement of the passenger ship is found to have changed by more than 2%, or its LCG is found to have changed by more than 1% of its length, the passenger ship should be re-inclined. Is that clear, guys? Am I clear? Clear, guys?
Yes, sir.
Yes, sir, clear.
Okay. Now, since this is a very, very critical experiment, why? Because if kg is wrongly calculated or obtained light ship, then all the calculations based on that will go for a toss. So it has to be conducted in the presence of a surveyor. An administration representative should be present to witness the inclining test, and the test result be submitted for review, and they will attest the inclining experiment or inclining test report. The result of inclining experiment is to be certified by the administration representative, and the same is included in the ship's approved stability booklet. If you see later on in ship stability booklet, there is an inclining test report included in your stability booklet also. The responsibility for making preparation, conducting the inclining experiment, and lightweight survey, recording of the data, and calculating the result is not of the administration. It is the responsibility of the shipyard or the owner or the naval architect. The administration is only to make sure that experiment is conducted in their presence, conducted properly, and readings taken properly. But the responsibility of making preparations and conduct of experiment lies with the ship owner and or in its behalf the shipyard or naval architect. The ship should now, when you carry out this experiment, ideally the ship should be as complete as possible at the time of inclining experiment. Now you'll say, sir, why as possible, as complete as possible? Why not complete? Well, yes, complete is fine. But the aim of the inclining experiment is not to delay the ship. The test should be scheduled to minimize the disruption of the ship's delivery date or its operational commitment. So now what happens? Suppose a ship is ready and suppose one generator has to come, which will take another 15, 20 days, 1 month to come. If you know what will be the exact weight of the generator, and if you know when it is placed on board, mounted on ship, what will be the kg of the generator, then you can carry out the test without waiting for generator, and you can make adjustments for the generator later on. However, if somebody says, I don't know what will be the weight of the generator, or I don't know what will be the kg, what is the kg of the generator when it is mounted, then guys, you have no choice but to wait for the thing to come and be fitted on the ship. Okay, so the ship should be as complete as possible at the time of inclining test. The test should be scheduled to minimize the disruption in the delivery and its operational commitment. The amount and type of work to be left, that means like I gave you the example of the generator. The amount of type of work left to be completed affect the accuracy of the light ship characteristics. So good judgment should be used. If the mass or center of gravity of an item to be added, like the generator, I gave you the example, cannot be determined with confidence, it is best to conduct the inclining experiment after the item is added. However, if you are sure, if it is acceptable, you know what you're going to add, then you can conduct without wasting time and without waiting for one single equipment to arrive. Is every point on this slide clear to everybody in the class, guys? Anybody has anything to ask? Tell me. All clear?
Yes, sir.
Yes, sir.
Okay. This I have already told you the objective of the inclining experiment. In the schools, what were we doing after that? We used to learn the objective of the principle of the inclining experiment. Now, what is the principle behind the inclining experiment, guys? Let us say when we conduct the experiment, ideally the ship should be in light condition, but it is not possible for people to go on board and conduct an experiment and the ship to be only in the light condition. There will be some additional weights, maybe some oil, some fuel, or maybe some people, the weight to incline the ship. So the displacement will not be exactly the light ship. So I'll call that as W experiment. This is my own term that I've coined here. That means displacement of the ship in the experiment condition. GM0 experiment, that means initial metacentric height of the ship in the experiment condition. Now let us say the ship is upright with this small W weight shown in yellow placed on the ship like this. Now on this ship, the ship is floating upright, and what will you do? You'll place a graduated batten on the bulkhead like this. This is like you fit a whiteboard on the bulkhead or wall of a room or a classroom. Same way on the bulkhead, this graduated batten is mounted. And to measure how much the ship will incline when this weight is shifted, to read the exact value, you use pendulum. So a pendulum is mounted. You keep the length of the pendulum little down. You see my pendulum is overshooting the thing. Why? Because when the pendulum inclines, then it should not fall short of the graduations. Which length of the pendulum will be counted as length of the pendulum? This will be the length of the pendulum up to the graduations, not up to the tip. Now, guys, if you shift this weight through the distance D, what will happen? The ship will list like this, yes or no? And we use the word incline. Will the ship incline like this, yes or no? Correct, yes, guys? Sir. What will happen to the graduated batten? Graduated batten was fixed on the bulkhead, so the graduated batten will also incline like this. Yes or no, beta? Am I right? Graduated batten will also incline, correct?
Correct, correct.
But what will happen to the pendulum? The pendulum will remain vertical because of gravity. The pendulum will remain like this. Now, we all know this angle theta is the inclination which is caused because of the shifting of the weight. Now, we know the formula. This inclination is what? This is list. And what is the formula for the list? List is, in this case, will be small w, the weight shifted, into small d, the distance through which is shifted, divided by w and gm initial. Correct, guys? This you all know is the formula for the list. So this is the inclination caused. Am I right?
Correct, sir.
And then you also have this right angle triangle here in green, in which this was the length of the pendulum. You can see on the left diagram also. And this one is called deflection of the pendulum. This is called deflection. And this angle obviously is 90, you know. So if this angle is 90, then in this right angle triangle, what will be tan theta equal to? Perpendicular upon base. It will be deflection upon L. Am I right, guys?
Yes, sir.
Yes, sir.
Now in these two equations, left side is tan theta for both. So the right sides can be equated. Is equal to deflection upon length. Now you take GM0 on one side and rest everything on the other side. This is the formula, which is the formula for inclining experiment. This will give you GM of the vessel in the experiment condition. Initial metacentric height. Guys, this you might have to do in the exams also. I hope now the way it has been explained, you'll be able to do not without much effort. Yes or no?
Yes, sir, correct.
The diagram has been drawn in steps so that you know exactly what is to be drawn and how it is happening. Okay. Now, guys, in this tan theta formula, this GM is what? Is it GM solid or fluid? In tan theta formula. Fluid. So obviously this GM is the GM fluid. Okay. If I have to get GM solid, what do I have to do?
FSC.
Add FSC. What do I do with the FSC? Divide by FSC or multiply by the FSC? What do I do?
Add FSC.
Add FSC. Very good. So this experiment gives initial metacentric height fluid of the vessel in which condition? Experiment condition. It may not be light. Now from here we can get the GM solid in the experiment condition by adding the FSC in the condition in which experiment was performed. Now we can go to the hydrostatic particulars, and for this displacement W, we can get the Km of the vessel. This Km can come from hydrostatic particulars, and when we subtract from Km this GM solid, we'll get the Kg in the experiment condition. Yes or no? Am I right?
Yes, sir.
Okay. So what does this experiment leads you to? It leads you to give you the Kg of the ship in the condition in which experiment was performed. Now, the experiment gives the Kg of the ship in the experiment condition. Now, if you want the Kg of the light ship, then you will identify the weights which do not belong to the light ship. And whatever principle of moments you have been using to calculate Kg, you can allow the same principle and from there obtain the Kg of the light ship. Do you agree with me? Yes or no?
Yes, sir.
Correct. Now there is one very important care which needs to be exercised. Guys, what is tan theta, sine theta, cos theta? What are they called in maths? Trigonometric. What next?
Trigonometric ratios.
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 And ratio means comparison. And comparison happens of like things. So come to this formula. Here you're comparing deflection and length of the pendulum. What do we mean by similar things like things here? It means that the unit of deflection and length must be same. Usually in your questions, deflection is given in centimeters and length of the pendulum is given in meters. Now, scientifically, both can be in centimeters or both can be in meters. It will be the same. What we do usually in our numericals is that we convert the deflection into meters. Otherwise, scientifically, theoretically, you can convert length into centimeters and use the deflection on centimeters, doesn't matter. But usually we convert deflection into meters. So caution, deflection and length of the pendulum must be in the same units before being used in this formula. Is that clear to everybody? Clear? Any questions on the principle? This can be part of your theory, and of course, this formula will be used in the numericals also, guys. Anybody else? Samir, clear now?
Clear, sir, clear.
हाँ, कितना पढ़ के जाएगा? इसके बाद पढ़ने की जरूरत नहीं होनी चाहिए भाई.
Yes, sir.
Okay. I don't have time. I was thinking of making video, but maybe another 2-3 months down the line, there'll be a video on this and all these small topics, but right now they're not there. There's hardly any time, honestly. Okay, guys. So principle of inclining experiment is clear, and the formula, please remember the formula, will need it for questions. Okay. We continue. Guys, in the schools, when we were doing experiment, what were we doing? Okay, what is the objective? What is the principle? Then what are the equipments required? Let's run through. Inclining weights. Inclining weight in this derivation was small w that we were talking about, the weights which are used to incline the vessel. Pendulum or other measuring devices which measure the inclination, like sensitive inclinometers or U-tubes. The guidelines. Now, guys, just for information, where am I teaching you from? Where is all this contained? This is contained in Code of Intact Stability. Okay. Presently, which Code of Intact Stability is applicable? Code of Intact Stability 2008 is currently in force. Okay. So whatever I'm teaching you from there. Okay. The use of 3 pendulums is recommended, but a minimum of 2 should be used to allow identification of bad readings at any one pendulum station. Now, 1 or more pendulums may be substituted by alternate inclination measuring devices like U-tubes or inclinometers at the discretion of the surveyor or the administration. However, the code strictly recommends that inclinometers or other measuring devices only be used in conjunction with at least 1 pendulum. Pendulum still remains the most reliable of all these. Efficient two-way communication between the central control room and the weight handlers, and between the central control room and each pendulum station should be there, because there'll be exchange of information that has to take place. So equipment, inclining weights, inclination measuring devices, communication systems, and it continues. Plans. There will be a set of plans required, and they include the following: lines plan, hydrostatic curves or hydrostatic data, GA plan, capacity plan, ballast water used in inclining if you are using the water ballast, which is not usually done, then proper location of the center of gravity of the tanks. Sounding tables, tank calibration tables, basically, draft mark locations, and docking drawing with keel profile and draft mark corrections if available. These are the, so you can just say a set of plans. For example, you can give 2, 3 plans if you don't remember everything. But yes, there will be certain plans and booklets like hydrostatic particulars, tank calibration tables, etc., which will be definitely required for the experiment. Clear, guys? Clear, class?
Yes, sir. Yes, sir.
Yeah. Scales for measuring pendulum deflection, which are already put on the bulkhead, the graduated scales. Sharp pencils for marking pendulum deflections on the chalk for marking various positions of the inclining weights. We'll put the inclining weights on deck before shifting and after shifting so that positions will be marked. A sufficiently long measuring tape for measuring the movement of the weights and locating different items on board. A sufficiently long sounding tape for sounding tanks and freeboard, taking freeboard readings. Why? Because you want exact measurement of drafts. Specific gravity hydrometers with range sufficient to cover density of the water where the ship is floating. Other hydrometers as necessary to measure specific gravity of the liquid in the tanks. So you may not remember all of them. Whatever you can remember is good enough. But primarily the inclining weight you can't forget. Then inclination measurement devices like pendulums, U-tubes and all that you cannot forget. Communication system you cannot forget. A set of plans you cannot forget. And then, of course, these are the small things. Why you need hydrometers? Because you'll need to calculate the displacement of the ship. You'll need thermometers to take the sounding of the temperature of the water outside, measure the density of the water outside, and all those things are required to evaluate the correct displacement of the vessel. Graph paper to plot inclining movements versus tangents. This you'll not require, but I'm just taking you through, don't worry. A straight edge to draw the measured water line on the lines drawing, forget about it. I'll just take you, I'll highlight the important things which you cannot afford to forget. A thermometer. Draft tubes if necessary. If there is a choppy weather, then by eyes you may not be able to get good draft. Then you should use draft tubes if necessary. Guys, so equipment, at least I'm sure 8, 9, 10 equipments you can write now from all this long list. Yes or no?
Yes, sir.
But do not forget the inclining weights. Do not forget the, what do you call the communication system. Do not forget the inclination measurement devices. Do not forget the plans. Do not forget the hydrometers. Do not forget the draft reading or measurement tapes. These few things you should not forget. Rest of the things, even if you forget, it's fine, right? Okay, what is the procedure? Procedure for the experiment, because in schools, what were you doing? Objective, principle, equipment required, the procedure. The inclining experiment, freeboard draft readings, and the survey may be conducted in any order and still achieve the same result. So 3 things have to be done. You have to carry out the inclination, you have to read the drafts to get the displacement, and you have to carry out the survey of the weights on board. Now they may be carried out in any order, any one of them first and anything second and then anything third. That is what it is trying to say. Initial walkthrough and survey is important to assess the readiness of the vessel for the experiment, especially as regards to the ship being complete. Securing of ship's weight in seagoing condition, derrick, cranes, everything should be housed. Installation of inclination measurement arrangements, installation of pendulums, U-tubes, etc. Inclining weight in their marked positions, tank conditions, availability of plans, etc. That should first be assessed before you start conducting the experiment. Then freeboard and draft readings have to be taken, of course. Seawater temperature and density has to be measured to get the correct displacement of the ship. The inclination is conducted by use of 4 weights, 2 on each side, and it basically results into 8 distinct movements. Now you'll say, sir, If you have 1 and 2 weight here and 3 and 4 on the other side, how does it result into 8 movements? 1, 2, 3. This one comes back 3. This one comes back 4. Now, this one goes here 5. This one goes here 6. This one goes back 7. And this one goes back 8. So 2 weights on each side result into 8 distinct weight movements. Is that clear, class? Have you understood the meaning of 8 distinct weight movements? Right?
Yes, sir.
Yes, sir.
Then to see whether your experiment is good or not, you usually draw a plot. This usually people don't write, but it's okay to know. A plot should be run during the test to ensure acceptable data are obtained. What plot is he talking about? In the plot, on the x-axis, you have the healing moment, small w into x, w into d. And on y-axis, you have the tangent of the angle of the heel. Deflection of the pendulum divided by length of the pendulum, which is tan theta. And then this is plotted line does not necessarily pass through the origin or any other particular point, for no single point is more significant than the other. All points, all the 8 points are equally important. When you plot and then you apply, you don't have to worry about these words like a linear regression analysis, which is a science process, is used to fit the straight line. OK. The plotting of the readings of each of the pendulums during inclining experiment aids in the discovery of the bad readings. OK. Okay. Now, how is it plotting is done like this, beta? You don't have to worry about it. First weight shifted. This is 1. This is about 1/3 of the weight shifted to starboard side. Then the second weight is shifted to the starboard side, maximum starboard movement. Then third is when you basically shift one back. Now one has shifted back, so you get the third point. Now you shift the second also back, and now you'll come to the origin as the 4th point. Then 5th goes here, and 6th comes here. Then you put the 5th one back, 7th, and now you have the 8th coming here. And when you join all these plots, you should ideally get a straight line like this. If you get a straight line passing through origin, your experiment is perfect. There's absolutely no problems. If there is a change from this, then there has to be a reason. OK, so you don't have to worry about this graph and all that. But this is if you ever come across in code of intact stability, it should make sense to you. Deviations from the straight line are an indication that there were some other moments acting on the ship during inclining. If it is not this, then there is something else which was also affecting the inclination. These other moments should be identified, their cause corrected, and the weight movements repeated unless a straight line is achieved. And this is how you make sure that experiment is effective, efficient. Then the code also contains some variations, for example, like this. If it gets deflected like this, what does it show? It shows cause that there is excessive free surface in the ship. Some more tanks are slack. What is the action you should take? Recheck all tanks and voids and pump out as necessary or reduce the free surface. After doing that, redo the inclining experiment all over again. Recheck freeboard and draft readings because you would have pumped out some tanks or filled up something. So please check your displacement again. If the graph is somewhat like this, on one side it is straight line, on the other side it has gone like curved. That means the ship may be touching the bottom, or restrained by mooring lines on one side. Action. Take water soundings of the sea. Check mooring lines if they're holding the ship, and redo weight movements. Which ones? Which are not on the straight line. 2 and 3. If the graph is like this, it is a straight line but shifted to one side, then maybe the vessel is experiencing wind from one side. steady wind from one side, and this is an acceptable plot. Nothing is required. You can continue your experiment. There's nothing to worry because you've got a straight line. It has gone off center. That's fine. No problems. If you get like this, where your couple of points here have gone off, what could be the reason? Reason is gusty wind from port side. 1 and 5 had gone out. Gusty wind from port side. Action, redo weight movements 1 and 5. So these are just examples to tell you that why that graph was important, because that graph will tell you whether experiment is conducted properly or not. I don't think you'll remember it for the exams, but nevertheless, anytime you want to study, at least these things should start making sense to you. Clear, beta?
Yes, sir.
Yes, sir.
Yeah.
And what do we close the experiments in the lab manual? We close with the precautions. The tide conditions and trim of the ship during the test should be considered, including sufficient underkeel clearance to ensure that the ship does not touch the bottom. Specific gravity, that is the density of the seawater, should be accurately recorded. The ship should be moved in a manner to allow unrestricted heeling. The gangways or access ramps should be removed. Power lines, hoses, etc. connected to the shore should be kept to minimum and must be slack, not to hamper the heeling of the ship. The ship should be as upright as possible with inclining weights in initial position. Accurate trim and deflection of the keel. Deflection of the keel is hog and sag, guys. If practical, should be considered in hydrostatic data. That means displacement should be obtained through draft survey method. It is very important that all weights, the number of people on board, remain constant throughout the test. All precautions are of common sense, guys. Nothing, nothing unusual here. Yes or no? Correct?
Yes, sir.
Correct.
It follows from the procedure only, actually. The total weights used should be sufficient to provide a minimum inclination of 1 degree and maximum inclination of 4 degrees of heel on each side. The use of 3 pendulums is recommended. The use of pendulums is recommended, but a minimum of 2 should be used. A minimum of 2 should be used to identify. Sorry, beta. Screen chala gaya? Is it?
Yes, sir.
My screen has gone.
आ गया, sir.
आ gaya? Okay,
No.
fine. Okay.
It's okay.
The use of 3 pendulums is recommended, but a minimum of 2 should be used to allow identification of the bad readings at any one pendulum station. So they ideally recommend 3 pendulums. 1 or more pendulums may be substituted by alternate devices. However, it is recommended that at least 1 pendulum should still be there. Efficient two-way means of communication should be provided between central control room, the weight handlers, and the pendulum stations. Weights such now, guys, the weights which you are using for inclining, you should know their exact weight. Now they should be ideally non-porous. That means they should not absorb water. If they are of the material which can absorb the water from atmosphere, then they must be weighed just before the experiment. Otherwise, ideally, they should not be the ones which absorb water. Each weight should be marked with an identification number like A, B, C, D, or 1, 2, 3, 4, whatever. The pendulum should be long enough. Now, we just said how much inclination is ideally required, minimum 1 degree, maximum 4 degree. Now he says how much length of the pendulum is, because the length of the pendulum will also read the deflection. So basically, the pendulum should be long enough to measure deflection to each side of the upright of at least 15 centimeters. Generally, you require a pendulum of at least 3 meters. It is recommended by Code of Intact Stability that pendulum length should be anything between 4 to 6 meters. One person at the central control station should be in complete command of the experiment. One person, okay, this is a report, sorry, this is a repeat of the point. I think it's all running in sequence. There's nothing to worry about. If you want any screenshots, let me know, guys. I'll give you.
Excuse me,
Okay.
sir.
Yeah, tell me.
Sir, I need to ask one thing. Sir, I have seen in some of the places that they have mentioned the bob of the pendulum needs to be immersed in the oil to dampen the motion. Is it correct statement or wrong, sir?
Beta, see, when you immerse in bath, it is only if there is a fear of oscillation, not always, not necessary. Why do you immerse anything in physics? Also, you have done so many experiments. Why there's a need to immerse anything in a bath, water bath or oil bath, is to dampen if there are oscillations, right? But if you're conducting in calm conditions, then there'll be no oscillations. So engines would be practically off, right? You may be using shore crane to shift the weights, correct?
Yes, sir.
So it is like this. You at one place it was, remember, you may use this draft tubes for reading the draft. Now it is not that every time you'll use draft tubes. If the weather is choppy, then you'll use the draft tubes, right?
Understood,
correct,
sir.
Peter? Okay,
Yes, sir.
so it is
you.
not must that you should use it, but yes, if there are issues, if there is something, because usually in this case you don't do that. Reason being that these are in sheltered spaces. They are inside the hold, right? They are not exposed to wind or something. It is not mounted on deck. Correct? And secondly, please understand, when the ship will incline, the viscosity of the liquid will also resist the inclination of the pendulum, right?
Correct.
Right. So if you bring a pendulum bath, when do you bring the pendulum bath? When the ship has inclined and the pendulum has gone to its position, that is where you'll bring a bath from underneath to stabilize it, right?
Yes, sir, correct.
Right? You will not basically have it dipped in the bob when upright, dipped in the liquid and then incline, because if you incline like this, the liquid will also resist the movement of the pendulum, no?
So that is correct, sir. But like in our MTI also they taught like this, that it has to be immersed. So that's why
it is not. It is not necessary. It is not necessary. What is the purpose? See, I have never said that don't use it. I said, what is the purpose of immersing in a bath? Purpose of immersing in a bath is to basically stabilize the bob so that you can get the readings, right?
Yes, sir, correct.
But if it is stationary, then why do I need to immerse it in water bath, right? Am I right?
Yes.
Correct?
Yes, sir, understood. Thank you, sir.
Yeah, so everything has a purpose, na? So if there is a need, you can use it. So basically, the surveyor will take a call that suppose, let me just give you an example. Suppose the ship's main engines are running. Suppose, though they will not advise. Why? Because when you're using main engines, the main engines are consuming fuel, right? Displacement will continuously change.
Yes, sir.
Understood?
Yes, sir, understood.
You usually in inclining experiments, you don't use the ship's crane. Why? Because if the ship's crane is used, then the ship is no more in seagoing condition, correct?
Correct, sir.
So usually it will be the shore cranes that we use. Usually you'll be on shore power. Okay, that is why at one place it was there. If the power hose is there, that should be slack, right? Power cable.
Yes, sir.
But nevertheless, all said and done, if there is a reason for which the pendulum is not stabilizing, water bath can be used. Why not? It is a way it is used in science. It can be used here also. Definitely it can be used. Okay.
Understood, sir. Thank you.
Okay, fine. So guys, with this, we come to end of the theory, and that should take care of your question number 9. If you see 10 papers, out of 10 papers, you'll definitely find this in at least 5 to 6 papers. Question number 9 on inclining experiment.
Excuse me.
Somewhere precautions and principle, somewhere principle and procedure, whatever it is, it's all common sense and it flows in a sequence. And of course, there are numericals also. So does anybody want any screenshots or something? Let me know, guys. If you have missed out anything, I can show it to you. Otherwise, I'll go to the numerical then. None? Okay, good. Then I
Sir,
go to the. Yeah, tell me.
just can you show the second last page for precautions?
This is the last. This is the second last. This one you're talking about. Then I'll go on the this thing's PPT display. Is this what you're
Yes.
talking about? Okay.
Yes, sir. I have taken already. Thank you.
Okay, you've taken the smaller one. Okay, fine.
Thank you.
Okay, guys. Now let's take a numerical. Please keep your. Okay, I have basically here also on the projection. This is okay. This will go on to the jump to the first one. Okay, it's here. Okay, guys, this is a question which is March 2022. MV Inship was floating with all compartments empty except as follows. Number 2 port and starboard DB tanks full of water ballast. Number 1 DB contained 100 tons of HFO. An inclining experiment was conducted in this condition. A weight of 10 tons kg 10.2 meters shifted transversely through a distance of 17.6 meters caused a deflection of 8.3 centimeters in the plumb line, that is the length of the plumb line of 8.5 meters, that is the length of the pendulum. Calculate the GM solid and kg of the light ship. So what the question wants is for light ship kg and light ship GM solid. Okay, guys. Now, can you recall the formula for GM initial experiment, guys? I'm sure you can recall the formula, correct?
Yes,
W. Yeah.
Small w into d into small l
Upon
w into
deflection. Very good. Guys, let's work out the experiment condition. What all was there on the ship in the experiment condition? One was the weight of the light ship. Light ship. What is the weight of light ship of the MV Inship? You can either take from the particulars in the beginning or you can take from condition number 1. Condition number 1 is the light ship condition. And if you see there, the weight is this much. 5499.8. Correct, guys? Yes or no?
Yes,
kg in the light ship condition is to be calculated, guys. And in the light condition, there will be no free surface in the ship and there will be no FSM in the ship. So in the experiment condition, you had the light ship. In addition to the light ship, which all weights were there, guys? Look at the question and please tell me one first weight. 2 dB port starboard full of water ballast. Am I right?
Yes, sir.
Yes, sir.
Correct. What will be the weight when both DBs are full of water ballast? See from here, guys. If 2 dB port starboard and is full of water ballast, can you use your calculator and give me the weight of the water ballast in both the two tanks combined? It's here on the screen on display. You just have to use the calculator. I can click and show it.
404.4.
No, sir, 4.92.
Beta 404.8 will be 100% cubic capacity. I'm asking weight of the water ballast. Okay, be careful. That's why I'm asking you. If you speak wrong, you'll learn it.
Yes, sir. Yes, sir.
414.305.
4.14.9. Correct, guys?
Correct, sir. Correct, sir.
Yes, sir.
What is the kg of these two tanks? 0.65. It is again here. Box is made 0.65. Correct, guys?
Correct, sir.
Once these tanks are full of water ballast, will there be any free surface moment in them? Will there be free surface?
No.
So they'll in the experiment condition, there was no free surface from here. What is the next weight on board when the experiment was conducted, guys?
So 1 dB.
100 tons of HFO.
Very good. 100 tons of HFO. Very good. Weight is given in the question. Now tell me, here the 1 HFO details have come. When 100 tons is there, is this tank full? Yes or no?
No, sir.
No,
How
sir.
much is the total HFO it can contain at 0.95 density? 157.6 into 0.95. Is that more than 100?
Yes, sir.
149.7.
And what is the kg of number 1 dB, guys? 1.14, right? You can see on the screen. So that means number 1 dB will be slack. So there will be FSM in number 1 dB. What will be the FSM in number 1 dB? 419. No, sorry, I is 419. FSM will be I into DI. My mistake. Sorry, I stand corrected. I into DI. Can you multiply and see? FSM will be 398.1. Correct?
Yes.
Now, guys, here I would like to warn you. So in some old stability particulars, this may be 6.1. There is some other value here. 600 something is there.
657.
657. But if you go to page 18, it is 419. Okay. So if that is a misprint in the book, then that's a misprint in the book. I have no answer to that. Am I right, guys?
Correct, sir.
Okay. So this 398.1 is based on I being 419. Guys, look at the question. Any other weight on board?
No, sir.
Read the question carefully.
10 tons. 10 tons, yes, sir.
Inclining
10 tons
weight, 10 tons. And what is its kg? 10.2. It's a solid weight, so we'll have no FSM, right, guys?
Right, sir.
What does this give you? This gives you in the experiment condition. Displacement of the ship in the experiment condition is 6024.7. And FSM in the experiment condition is 398.1. Does everybody agree?
Yes, sir.
Yes, sir.
Correct. So guys, now I have GM0 in the experiment condition. We'll use this formula, correct, guys? Small w into d into length upon w experiment into deflection, correct?
Correct, sir.
How much is small w in this question? Please tell me the value.
10.
10.
10 tons.
10.
What is small d in the question?
17.6.
Very good. 17.6 meters. How much is the length of the pendulum?
Sir, 8.3 centimeter.
No. Length of the pendulum. Be careful. Be careful. But I'm happy you're speaking, because if you're speaking and you realize that you're making mistakes, you'll correct them. Otherwise, you'll make these mistakes in the exam. Length of the pendulum is 8.5 meters, guys.
8.5.
Yeah. What is the W in the experiment? W experiment, guys? What is the deflection? Okay, give me deflection first.
Deflection is 8.3.
8.3 centimeters, but we'll have to convert this to meters.
0.83.
Very good. 0.083 meters, right? Beta, please, beta, if you're not
0.083
talking to
meters.
Yash and company, could you mute yourself? Okay. What is the W in the experiment condition? 6024.7.
Yeah,
Sorry, beta. Sorry, yeah, that's a typo error. That's a typo. Thank you. That's a typo error. Okay, that's a typo error. Okay. W experiment 6024.7, guys.
Yes, sir.
Correct, sir.
Now we have everything which will give us GM initial in the experiment condition. Can you calculate how much will be the GM initial in the experiment condition?
2.992.
Okay, 2.992. Very good. And what will be the FSC in the experiment condition? Let's calculate that also. Give me the value. The table is guiding you. FSC in the experiment condition.
398.1.
0.0647.
Very good. 0.066, guys. Am I right?
Correct, sir. Correct, sir.
Okay. Now we can calculate GM initial in the experiment condition. We put these values and we get 2.992 meters, right? This will be GM fluid, right?
Yes, sir.
Correct,
Yes, sir,
guys?
GM fluid.
Then GM solid in the experiment condition will be 2.992 plus 0.066 FSC. And that becomes 3.058. Am I right?
Yes, sir.
Any questions up to this point, guys? Now, we need km to get the kg in the experiment condition. For what displacement will take the km now, guys?
6024.7.
6, very good. Very good, very good, very good. Here comes the hydrostatic particulars. Get me the km, interpolate the km, so that if there's a misprint in your books, we don't have different answers. So I have shown it here. (11.234) and 10.834 interpolate for the W experiment.
(11.113).
Okay. 11.113 is correct. Guys, have you got it?
Yes, sir.
And this will lead us to kg of the ship, not in the light condition, but in the condition in which the experiment was performed. So kg in the experiment condition will be 11.113 minus 3.058. This will be equal to 8.055 meters. This is still not the answer, guys. We are going to continue, but so far we have got the kg in the experiment condition, correct? Shall we continue, guys?
Yes, sir.
Yes, sir.
Okay, now. W experiment is 6.6024.7 kg in the experiment condition. We just calculated 8.055 meters. In the table, can you identify the weights which do not belong to the ship in the light condition, guys? Which weights do not belong to the light ship condition?
Is
Water
2
ballast
dB,
and
1
HFO.
dB.
1 dB and inclining. These are the weights which do not belong to the light ship, correct?
Yes, sir.
And their kgs are also there. So by principle of vertical moments, we can get the kg of the light ship. Kg of the light ship will be the vertical moment in the experiment condition minus the vertical moment of the water ballast in 2 dB minus the vertical moment of HFO in number 1 dB minus the vertical moment of the inclining weight. Now this will be the vertical moment of the light ship. Am I right, guys? Correct?
Correct, sir.
And if I divide this with the light ship displacement, I'll get the light ship kg. Correct, guys? Instead of this, if you want, you can put directly 5499.8. I have just followed the principle of moments, right?
Anji, sir, correct.
This is one answer, guys. He wanted the kg of the light ship. Now, tell me, what can I do to get the GM solid of the light ship?
Sir, KM
How do I
light
get
ship
the
है
GM?
अपने पास.
KM for the light ship displacement of 5499. Now for 5499.8, we get the KM from here, which is 11.6651 if I'm not wrong. And then this will give you the GM solid in the light ship condition equal to 2.916 meters. And that is the second answer to the question. Subject to any clerical errors, they can always be corrected. Okay. But fundamentally, we have gone through the question. Class, is it clear?
Yes, sir.
Samir, clear a bit on numerical?
Yes, sir, clear, sir.
Okay. Anybody else who has a doubt on this numerical? Because numericals will be on the similar pattern, or they can be non-hinged, like the next one. I think this is straight. Can you please calculate the kg? This is not from MMD. I just randomly put this here so that you can apply the formula once again. Please find out the kg. Obviously, you are going to find out in whatever condition it is given.
The 6.692.
Okay, we'll just check with
Yes, sir. 6.692.
Okay. Right. Correct, beta?
Yes, sir, correct.
Okay, with this we come to end of this first topic, guys, of the miscellaneous. That is the inclining experiment, one of the most important topics from exam perspective. Guys, last 10 seconds for anybody to seek any clarifications on this or anything you want to take down from anywhere. Please let me know. Otherwise, I'll be closing this presentation then. Guys, will you be able to address the theory question now without much effort?
Yes,
Yes,
sir.
sir.
Yeah,
Yes.
fill up pages, but fill up with sensible stuff. Okay, I'm closing it. Let me correct that meter before this one. This was an oversight on my part. Okay. And there was somewhere something was repeating also, no? This was repeating here. Guys, do you need a minute or two break before we start the next one? Or shall I bombard? Guys, the second important topic from examination perspective is this one. Heel during turning. Again, many of you may have gone through past papers and you may have come across this particular question. Okay. Now, guys, in schools, we would have all learned that whenever a cyclist takes a turn, he leans inwards into the turn. Again, we would have also learned banking of the roads. The outer side of the curved turning rod is raised up. Why? So that when the car takes a turn on a circular turn, the car can take a circular turn and it can, because the outer side is raised up, it inclines inwards. So we know two such examples where the body is in healing or turning or inclining towards the center of the curvature. Class, yes or no? Correct? Correct, guys? Why
Yes,
do
sir.
they incline inwards? Is because they have to produce a force which is acting towards the center called as the centripetal force, because always a force is required. Whenever a body is in a circular motion, you need a force to keep it in the circular motion, and that force is called as the centripetal force. And this force acts towards the center of the curvature. This word you would have heard in the schools also, and you would have learned a formula in the school which needs to be recalled today. The formula in the school for centripetal force was this. Now in this, pay attention to the units. Centripetal force was coming in newtons if the mass was taken in kg and speed v was the velocity or the speed of the object in meters per second. Pay attention to the units. And r was the radius of the curvature in meters. This is a formula from pure physics, and I know this is done in the schools. We had also done it, and I am sure some of you can also recall this formula from school days. Am I right, guys? Yes or no? Correct, Peter?
Yes, sir.
Now, guys, please pay attention. In physics, in stability, we have taken a lot of liberty of calling mass as weight, weight as mass. We said ship's weight is in tons. Right? Tons is a unit of mass. How can it be unit of weight? So we have taken a lot of liberty, but today the formula on display is a formula from pure physics. And in this formula, when you say m, this is mass, and this cannot be taken as weight. Is that clear, beta? Am I right? Correct, beta?
Okay, sir.
So
Yes, sir.
today, when we use the word as weight of the ship, the next question which arises is, which is the force, which force is giving the centripetal force? Now, guys, in different situations, different forces take over the role of centripetal force. For example, if you take different examples of rotation, the force that acts as centripetal force depends on which case of uniform circular motion are you talking about. For example, if you tie a stone of a string and whirl it around in a circular motion over your head, then the centripetal force is provided by the tension in the string. You see, this tension in the string here is responsible for providing the centripetal force, and that is what keeps the string in the circular motion. If you talk of a cyclist who's turning inwards, the horizontal component of his reaction provides the centripetal force. If the cyclist turns like this, then his weight acting downwards, sorry, his reaction, which is acting like this, reaction acts like this, can be resolved into two components, r sine theta and r cos theta. R cos theta, the horizontal component of the reaction, provides the required centripetal force. In case of Earth-Sun motion or Earth-Moon motion, though it is elliptical, but it is nearly circular. So you have the sun and you have a planet here. What is keeping the planet in the circular motion is the gravitational pull between the two bodies by Newton's law of gravitation is what is responsible for providing the centripetal force. So what am I trying to convey through these three examples? That every case of rotation, circular motion, you do not have the same force providing the centripetal force. In case of that stone case, the tension in the string was providing the centripetal force. In case of cyclist, it was the horizontal component of the reaction that was providing the centripetal force. And in case of Earth's planet sun motion or Earth moon motion, it is the gravitational pull between them which is providing the required centripetal force. So one thing is undeniable, that if a body is in circular motion, there has to be a centripetal force. From where does the centripetal force comes? That will depend, that changes from case to case. Do you agree with me through these three examples, guys? Yes or no?
Yes, sir.
Okay. Now, So you see here is the cyclist. His reaction R cos theta provides the required centripetal force. Now, guys, there's a blank sheet. Where is that gone? Where is that gone? Blank sheet is gone where? That was here, no? Yeah, so where is it gone? That is the derivation. Okay, so that means I'm skipping this page. Okay, let me just do it here. Now, guys, you see, when you said you were whirling the stone like this, and tension in the string acting like this one. Correct? If the force is acting like this, the stone should move to the center. Or if in Earth Moon case, if there is a gravitational pull, then Moon should come and hit the Earth. But none of them are happening. So that means there must be some force which is acting opposite and balancing the centripetal force. Firstly, what provides the centripetal force changes? But yes, centripetal force is must, then there must be a counter to it. Guys, when we were in the schools, we were taught that there is an equal and opposite force called as the centrifugal force. And when we were taught, it was taught based on Newton's third law of motion, that to every action there is equal and opposite reaction, so there is a centrifugal force. But today, it is not so. Today, when they teach in the schools, it is not taught as an action-reaction pair. Why? Because they say for action-reaction, there have to be two bodies. That means you push the wall pushes you back. So now, the centripetal and centrifugal forces are not taught as action-reaction pair. Now, what do they say is that yes, if the stone is not coming to the center, if moon is not coming and hitting the earth, or earth is not going and hitting the sun, then there must be a counter force balancing the centripetal force. And that counter force is called as centrifugal force. Now, what do the physicists say now? Where does it come from? They are saying it's a pseudo force. Pseudo force means fictitious force. So why they are saying there is pseudo force? Because they don't know from where it comes, but they are saying since the stone is not come to the center, something must have balanced it, and there is a centrifugal force. Then there is, so today when they talk of centrifugal force, they talk of it as a pseudo force, which is equal and opposite to the centripetal force. With this, let's go to the derivation. Now, guys, first, when you put the ship's rudder to, let us say, port side, port is just an example. What will happen? If you have the ship, if you have a ship like this, and you have the rudder right at the bottom, and now you put the rudder to port, what will happen? When the water resistance acts on it, what will happen besides doing turning and everything? It will also cause this lower part of the ship to be pushed this side. Yes or no? Am I right, OS? Correct?
Yes.
And this will cause the vessel to heel little bit to port. So if the ship's rudder is put over to port, the forces of the rudder cause the ship to initially heel slightly to the port, that is inwards. We are not interested in this heel. Why have I brought it in here? Because tomorrow somebody takes ship handling with you, then he'll talk about this heel and then you'll say, we were never told about it. I'm telling you, yes, there will be an initial heel of the ship inwards. So if she's put hard over to port, she will heel to port. If it is put hard over to starboard, she'll heel to starboard. Okay. However, as the body moves in a circular path, it requires centripetal force to keep it in the circular path. We have just discussed that. In case of ship turning in a circle, what provides the centripetal force? That's important. It was tension in the string in one case, it was horizontal component of reaction in the second case, it was the gravitational pull in the third case. So in our case, what provides the centripetal force? This centripetal force is provided by the water resistance acting on the side opposite to the turn. So it is the lateral water resistance acting on the side away from the center of the turn. And it is this water resistance, which is the force, which is responsible for providing the required centripetal force. Entire centripetal force can be assumed to be acting through its center of force, like your center of gravity, center of buoyancy, center of pressure. Likewise, centripetal force, which is because of the force on the underwater area on the opposite side, then there will be a point through which the entire force can be assumed to be acting through. What are we talking about, guys? If a ship is like this and she's turning, it is because of this underwater area on the opposite side. Where can this be assumed to be acting through? It can be assumed to be acting through the geometric center of that underwater area. Now, where will the geometric center of this underwater area fall? It will fall somewhere near to, not exactly, half the draft or more or less in line with center of buoyancy. It's a small assumption. Is it exactly in line with center of buoyancy at the same level? Not necessary. Is center of buoyancy of take the centrifugal force, because it's a pseudo force. It is not created by anybody. It all through the center of gravity of the body. It will always act through the center of gravity of the body. This force acts through the center of mass or center of gravity. These two equal and parallel forces form a couple. Guys, before I show it to you in the diagram where it'll make sense, if any of these points needs more explanation, please let me know. Any of these points you have not understood, which you want me to explain and elaborate more. So we are not talking of this heel. We are talking once she settles in a circular motion. Okay. Now see here. Here is the ship. Here is the center line. This is the center of buoyancy. Here is the center of gravity. Now you have put the ship. She's going in a circular turn on the port. Okay. Which area will the lateral water resistance will be experienced by which area, which provides the centripetal force? This area, which I have highlighted in yellow, you see when the ship is turning, this area is pushing itself outwards towards the end, is experiencing water resistance. Do you agree with me, guys? Yes or no? Correct?
Correct, sir.
This one exerts the lateral water experiences the lateral water resistance, and this force is responsible for providing the centripetal force in case of the ship. Where will it act through? Through the centroid of this area, and that centroid of this area is assumed to be in line with center of buoyancy. So the lateral water resistance of orange shaded area provides the required centripetal force. This center of force is the centroid of the area, which is assumed to be at the same level as center of buoyancy. And what is centripetal force? mv square upon r, we did on the first slide. Now, the moment this centripetal force comes into existence, and if there was nothing to balance it, then the ship should go to the center of the turn. But what happens? There is a pseudo force which comes into picture, which is centrifugal force mv square upon r, and that will always act through the center of gravity of the body, in our case, the G. So ship is turning to port, centripetal force is acting towards the center of the turn, and centrifugal force comes into existence and it acts outwards from here. Have you understood, guys? Yes or no? Clear, beta?
Yes, sir. Yes, sir. Clear.
Now you have two forces which are equal, which are parallel and opposite. They form a couple. And the couple will have a tendency to will have a moment, and that will heel the ship. Now see the direction of the couple. Will it heel the vessel to starboard or port?
Starboard, sir.
So this will start heeling the vessel to starboard. As the vessel starts heeling to starboard, the righting moment will come into picture. Now, wherever the heeling moment and righting moment become equal, that will be the new position of equilibrium. Do you agree with me, guys? Yes or no? Correct?
Yes, sir.
This moment will start heeling. And what will oppose the heeling? The righting moment. And at some angle of heel, an equilibrium is reached. At this angle on starboard side, the vessel comes to an equilibrium. She's turning to port, and this is where an equilibrium is reached. Now, in this condition, what has happened? Buoyancy has shifted to B1. Buoyancy has shifted to B1. And now, guys, what happens in this case? The heeling moment and righting moment have become equal. Now, in this condition, where is the centripetal force acting through? Centripetal force, since it was assumed to be acting through B, B and B1 shift vertically will be immaterial because you've already made an assumption that this was an assumed point because it was assumed to be in the same line as the centroid. So whether it is B or B1 does not matter. So centripetal force continues to be we continue assuming that it is acting through B. Now centrifugal force acts through this. Now, guys, in the equilibrium condition, what will be the lever between them? The lever between them is the perpendicular distance. Do you agree GX is the lever of the couple now? GX is the lever of the couple, yes or no?
Yes,
correct,
sir.
class?
Yes, sir.
Okay. Now, if GX is the couple of the lever, this angle is 90 degree. This angle is theta, the angle of heel. So in this small triangle that you have made, okay, now in the equilibrium condition, guys, look at the right diagram. What is the heeling moment? Heeling moment will be equal to what will be the moment of the couple here? One of the forces multiplied by lever. Lever is Gx. What is one force? mv square upon r. So one of the forces into Gx. Do you agree this is the heeling moment in the equilibrium condition? Yes or no? Correct?
Correct.
And in the triangle, what will be Gx equal to? Gx will be equal to Bg cos theta. Correct, beta? Gx is equal to Bg cos theta in this triangle, right? In this triangle, Gx is Bg cos theta. Yes or no, beta? Out here. Look.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
So Gx has been replaced by Bg cos theta. This is the heeling moment. What is the righting moment which has struck an equilibrium? What is the formula for righting moment, guys? What is the formula for GZ? Sorry, W into GZ. And today, since we are talking of force, W has to be mg. Correct, beta? I started off with that, right?
Yes, sir.
So the righting moment will be W into GZ, which is M is the mass of the ship in the above formula. So it is mg into gm sine theta. Correct, beta? Yes or no? GZ is gm sine theta, weight is mg. Correct? Correct, class?
Yes, sir.
Yes, sir.
And why the ship stops healing more? Because now the healing and the righting moment have reached equilibrium, so they are both equal. So if I equate them, what do I get? This implies mg into gm sine theta, which is the righting moment, becomes equal to the healing moment mv square bg cos theta. And if in this, if you bring sine theta by cos theta, then tan theta on one side, m and m will cancel out and take everything else onto the other side. And then you are left
P
with this
square PG
formula.
upon R.
Correct, guys? V square
Right,
Bg
sir.
upon Rg into Gm with Gm, initial Gm with Gm, fluid Gm. This is the formula for heel during turning. This is the formula for heel during turning. Way back in 2013, this derivation was asked. It has not been asked thereafter. Okay, but yes, it has been asked once for sure. Guys, one more thing. In the last inclining experiment, there was a caution. What was the caution? Unit of deflection and length should be same. Please remember the formula for centripetal force. In that, what was the unit of speed? Meters per second.
Meter per second.
Usually in our questions, the ship speed is given in knots. Please do not forget to convert that to meters per second before it is used in this formula. Caution, V must be in meters per second for the reasons I have just shared. Correct, guys? Yes or no?
Yes, sir.
Okay. So formula you'll have to learn. And in case the derivation comes, you can take a screenshot of this slide and whatever best you can explain and do it. Okay, beta? Clear, class?
Yes, sir. Yeah.
Okay, so we are good to now move on to the questions. This is MMD November 22. MV Hinship is at a draft of 7.4, 8.62 kg, so much FSM, so much speed, 13 knots. She turns in a circle of radius, it's so much. Now we have to find the heel produced. Guys, can you please find out the height draft first? Because we'll need KB for BG. We'll need, what else do we need? We need KM for GM. So we'll need to interpolate some particulars. So can you please find out the hydrostatic draft for 7.4 and 8.62? Particulars are on display, guys. This is LCF. Is it 8.018? Please check.
Yes, sir.
Right, guys? Samir Babu, what is the height draft?
सर कैलकुलेट कर रहा हूँ.
Got it? Samir, yes or no?
Yes, sir.
No, got the high draft, yes or no?
Yes, sir. Got, sir. Got.
So look at the formula, guys. For BG, we have the kg, we'll need kb. For GM, we'll need km. And for FSC, we'll need W. So what all do we need to interpolate? We need to get displacement, kb and km. Can you please get these three values for 8.018? You see, I can just show it, but again, many of you would not do it. So it's might as well practice once in the class here. The interpolated values are on display. You can check your interpolated values.
Yes, sir, correct.
Correct? Okay. Good. Anybody who's still interpolating and wants me to wait, beta. If you're not doing, then we might as well continue. If you're doing, I'll wait.
Okay.
कर रहे हो? Okay, करो, करके बताओ.
नहीं सर, हो गया.
Okay.
Done.
Okay, guys. Can you please calculate? Can you convert the speed into meters per second? Convert the speed into meters per second. 13 knots.
6.68.
13 knots means 13 nautical mile per hour. Convert nautical mile into meters and hours into seconds. And 1 nautical mile is 1852.3 meters. So in the numerator, you will multiply by that like this.
6.6877.
Yeah, 6.689 meters per second, beta. Is that
6.688.
yes? You round off to it will become 689, right? What mistake did you make, beta?
नहीं
सर
सर
मैंने ये किया
6.688.
सर
Sorry,
मैंने
say again.
1852 से ओनली इनटू किया मैंने.
Okay, fine. ठीक है, then it's okay. Guys, can you please get the BG of the ship? Because we need BG in the formula. Now my eyes are on the formula. BG. How much is BG?
2.739.
Okay. Can you please calculate the GM of the vessel?
1.252.
Okay, 1.252. Somebody else? Do you want to validate it?
Correct, sir.
Then it'll
One.
It's 1.180, my friend.
Yes, sir. 1.180.
Okay, good people are making mistakes. They'll realize. Beta, did you realize you missed out FSC completely?
Yes, sir. Yes.
Okay, so be careful. Such simple questions can, once you come out, then you'll feel like banging your head in the wall here. If you make these mistakes, please be careful. Now we have everything. Radius is given in the question. G we know is 9.8 meters per second square. We just have to put them in the formula. What is the theta that is coming, guys? Calculate.
1.515
Okay.
degrees.
Okay. You said how much? I'll write here. Point.
Sir, 1.515 degrees.
1.515
Degrees.
degrees. Is he right, guys? Is Samuel right?
Yes, sir.
So 1.16.
हाँ ठीक है सर 1.516 सर.
Okay, 516.
I think
515.
1.516.
Okay, 516. I'll make it, no problem. Okay. Now, guys, you can't stop the answer here. Based on the question, either you have to name port starboard if the question permits you to do that. If the question does not permit you to name it like this, then you have to name it outwards or inwards. Is that clear?
Yes, sir.
Right? Now,
Right, sir.
where is the cyclist now? Somebody can, in orals can ask you, or in theory also it can come. The cyclist inclines or inwards. Why does the ship usually inclines outwards? It is because the kg is usually greater than kb. So what was happening? Through B, centripetal force was acting. G, which is higher, centrifugal force was acting, and it was heeling the ship outwards, correct? Am I right? Correct,
Yes, sir.
Vita?
Yes. Correct.
And if you create a theoretical situation or an actual situation in which kg is less than kb, then that vessel will heel into the turn, correct, Vita? Am I right?
Yes,
Correct.
sir.
Okay, so in this case, is kg greater or kb greater? Please compare.
kg.
Kg. So in this case, since you can't name port starboard, you'll say outwards. Understood? It is 1.516 degrees outwards, and why? As kg is greater than kb. Is that clear?
Yes.
Is that clear, class?
Clear, sir.
Okay. If the question said she's turning to ports, then you will name port starboard, whatever it is. If port starboard is not possible, then you can name outwards, inwards. Okay. In this case, it is outwards because kg is greater than kb. If it was other way, it will heel inwards, right? Can I move on from this question, guys?
Yes, sir.
Yes, sir. Yes.
Okay, good. Okay, can you quickly calculate this one? This is a November 17 question, guys. And in this, you can take 1 knot as 1852 meters per hour because, no, yeah, 1 knot is equal to 1852 meters per hour because this is given in the question this time. So can you please find the list or the heel rather, not the list, heel produced because of turning? Give me the answer, final answer. Everything is given in the question here.
Four point nine three four.
0.93.
Okay. You have not given me the complete answer, my friend. That is what I was waiting for. This will cost you a couple of marks and then that can make a difference to your result, beta. Give me the full answer.
4.934 starboard.
Okay. Is he right? Don't miss out on my small things here. 4.934 degrees to starboard, right? Now here, he has not given me the kg. So what have I done? What have I done?
Assume that kg is more.
But you have to write
पोर्ट
it.
दे रखा है ना तो उसका आउटवर्ड मूवमेंट्स का वो
किसका बेटा?
शिप टर्न टू पोर्ट है ना सर.
No, but in this question that he has given you GM directly, is not given you kg. Understood?
assume करना सही.
Assume ही करना पड़ेगा. Normally it is, so you have to say assuming kg is greater than kb, right? Otherwise this question does not, he is not neither given you km and gm. If this was given, I can get kg, or he has to give me kg directly. But is there any indication of the kg here, whether it is less than kb or more? No, na? Correct, beta?
Correct.
Yes, sir, correct.
Okay, so usually it will be more, so that you can write like this, no problems. Close your answer.
So नहीं
Okay,
दिए
guys.
तो नहीं लिखेंगे तो भी चलेगा ना सर.
बेटा इसमें नहीं लिखोगे चल जाएगा, बट और किसी में अगर यहाँ पे केजी दिया होता और फिर पोर्ट स्टार्बोर्ड नहीं लिखोगे तो प्रॉब्लम हो जाएगा, है ना?
Okay, sir.
Yeah, so because here is said port, here of course you can always argue that I didn't know what the kg is. But what I'm trying to say is it's not the question. You see, you're not going to be there to defend yourself with the evaluator, right?
Yes, sir.
Yes, sir.
Yeah, so that's all I'm saying. But you must say you're assuming this, because otherwise somebody can say how starboard here. Okay. Guys, this is the formula and we apply for but last bit of it. Guys, this formula tan theta is equal to V square into BG upon RG GM. Was it derived for any particular type of ship like tanker, bulk carrier, passenger, timber? Was it for any special type of ship? No. It applies to every ship type. Okay. Even the passenger ships. But in the intact stability, code of intact stability, where you have all the stability requirements which the ships are required to comply, the passenger ships have some special requirements as well. Now, what are the special? Now, these are the special ones. Special besides what? Besides the other stability criteria, which is on page 5 of your advanced ship. There is a special stability criteria applicable only to passenger ships. When you say when there is a special criteria, what does it happen? The ships have to demonstrate that they are meeting the requirement. They are complying with it. Like when you are doing GZ curves, you must have satisfied and seen whether the ship is meeting the intact stability criteria or not, as per page 5 of your MV in ship stability booklet. Do you remember that, guys? Yes or no? Correct. In GZ curves, were you doing those questions?
Yes, sir.
Okay. So in case of passenger ships, besides those stability criteria, you have to satisfy 2 more. One of them is not for discussion in this topic, but I have just brought it here because there are only 2 of the special ones. 1, the angle of heel on account of crowding of passengers on one side shall not exceed 10 degrees subject to following assumptions. And guys, whenever there is a compliance to be demonstrated, what will IMO do? They'll say assume this, assume this, assume this, and now show your compliance. Why? Because if all passengers crowd on one side, okay, number will come from the capacity of the ship. But what should be the weight of each passenger? You will have the IMO has to specify. That's an assumption. What should be the kg of the standing passenger? What should be the kg of the sitting passenger? Those are the assumptions they have to give so that you can demonstrate your compliance. So the angle of heel on account of crowding of passengers on one side shall not exceed 10 degrees subject to following. That the weight of each passenger is assumed to be 75 kgs. Like when they say the lift is for 4 persons, then they assume the weight to be 75 or 80 kg, whatever given. The mass and distribution of the luggage shall be approved by administration. The kg of the standing passenger shall be 1 meter, and the kg of the sitting passenger shall be taken as 0.3 meters. With these assumptions, you demonstrate that if everybody crowds on one side of the ship should not heel more than 10 degrees. This is one of the special intact stability criteria only for passenger ships, and the ships, when they are built, they have to demonstrate this compliance. Likewise, the passenger ships have to demonstrate one more thing, because they don't want to cause discomfort to the passengers. They have to demonstrate that the angle of heel on account of turning shall not exceed 10 degrees. Now, guys, we just saw this angle of heel on account of turning depends on the kg of the ship. It depends on kb of the ship. It depends on the speed of the ship. It depends on the gm of the ship. It depends on radius of curvature, radius of turn. So if I have to demonstrate my compliance, I have to fix all these now. Sometimes I may be moving at full speed, sometimes I may be moving at half speed, sometimes I may be moving dead slow ahead. Sometimes I may be taking a turn of 400 meters, sometimes I may be taking a turn of 500 meters. So if I have to demonstrate compliance, for what values do I have to demonstrate this compliance? Understood, guys? Yes or no? Correct?
Yes, sir. Correct.
So when you have to demonstrate this compliance, what is the requirement? Angle of heel on account of turning shall not exceed 10 degrees. But to demonstrate, you have to demonstrate using the following formula. This is from Code of Intact Stability. The healing moment, which we had calculated, we calculated healing moment as mv square upon r into bg cos theta. This formula they don't want for compliance. For compliance, they want healing moment to be calculated using this formula. And you'll have to learn this formula in case this question comes, guys. It has come once, so that's why I'm doing it. In this, MR is the healing moment, and pay attention to the units. It's in kilonewton meter. Kilonewton, not Newton. So kilonewton will be when you take the mass in tons. Ton into G. V naught is the service speed in which units? Meters per second. L is the length at the water line. Delta is the displacement of the ship. Kg is the kg of the ship, and D is the draft of the ship. So this will give you the healing moment, and you'll have to equate it to the writing moment and see that she does not exceed more than, she does not heal more than 10 degrees. So you can learn this formula, okay, and use it in the exams. But I'll tell you how this formula has been arrived at. It is not there documented in the Code of Intact Stability, but I'll tell you what. Our healing moment was mv square upon r into bg cos theta. Okay. Now, in this, what have they done? They have said cos theta. How much is cos theta coming? Can you check on your calculators? Cos 10, how much is it? Cos 10.
0.984.
It's nearly 1, correct?
Yes.
So they are saying take it as 1. Don't worry about it. What is BG? BG was kg minus kb. They are saying for this compliance, you take kb as d by 2. So this becomes BG. Okay. Then what is this V? They said take it as service speed. M is the displacement mass of the ship in tons, displacement in tons. Pay attention. So this was M here. And then what is the radius? For this formula, they have assumed that the radius is 5 times the length. So in our formula, M is replaced by delta. V is replaced by V naught square. Bg is replaced by kg minus d by 2. And radius is replaced by 5L. 1 by 5 becomes 0.2. And denominator you are left with L. So have you understood how this formula has been arrived at, guys? So in case you slightly forget something, if you can remember what I am telling you now, probably that can be an aid to rewriting it if in case of a small confusion in the exams. Is that clear, beta?
Yes, sir.
Yes, sir.
Yes, sir.
Now, don't go by MV inship. In MV inship, they have made it, I think, point 0.02 because they have just not taken G there. So don't go by that. This formula is directly from code of index stability, guys. So don't get trapped out there. Okay, so here is the formula. If anybody wants to take a screenshot, let me just show it again. You can take a screenshot now if you want. And based on this formula, there was a numerical way back in 2013 when derivation was asked. So now, firstly, it should be clear to you when this formula is to be used. This formula gives you right one healing moment, does not give you angle of heel. And this has to be used only when you have to demonstrate compliance. Otherwise, that formula, tan theta formula, is applicable to all types of ships. Guys, this is a November 2013 question I was talking about. And I think it was question number 5, if I'm not mistaken. Can you see part A, derive an expression for angle of heel of a vessel during turning? That means he's talking of tan theta formula. Right, guys? The second is passenger ship of length 220 meters, displacement 21,000 tons, draft 10 meters, kg 8 meters, km 8.8, has a service speed of 18 knots. Does she satisfy the intact stability criteria regarding heel during turn? Please pay attention to this expression. Is it now clear that in this condition, the healing moment has to be calculated by that formula? Yes or no? Am I clear, class? Okay, let's do this. This question has not been solved by me. Let me do it here. Just now, what did we say? Healing moment in kilonewton meters. MR in which units? Kilonewton meter will be equal to V naught square into displacement into kg minus d by 2 into 0.200 upon L. Am I this? I don't know the sequence. I keep writing by recalling that formula. Have I missed out anything, guys? Can you check from your screenshot? Is everything there? Is this correct? Can you check from your screenshot if you have taken? Is the formula right? Bolo bhai?
Yes, sir. LWS.
Right, sir.
Yeah, okay, right. Then can you calculate V naught in meters per second? V naught will be equal to, it is 18 into 1852.3 upon 60 into 60. How many meters per second does it translate into up to 3 decimal places, guys?
meter per second.
5?
9.26.
26?
2.
262 meters per second. Okay, fine. So guys, I'll bring point 2. It was in the formula first, followed by V naught square, 9.62 square into displacement 21,000 tons into kg minus d by 2. Kg is 8 meters. D is 10 meters. So that is the numerator divided by length equal to 220 meters. This is the healing moment in kilonewton meter. Guys, when we are deriving the formula, the healing moment has to be equal to righting moment. And what is righting moment equal to? What is righting moment equal to?
Displacement into GZ, sir.
Displacement into GZ. And this time it is in kilonewton meter. So displacement will be in tons into acceleration due to gravity. So it will be 21,000 m into 9.81 g into GM initial. What will be GM initial, guys? KM is 8.8, KG is 8,
8.8.
and there is no FSC given, right?
Yes, sir. 0.8
So
आएगा.
into
Sin
0.8
theta.
into sine theta. 21,000 tons gets cancelled. And now you can calculate theta by sine inverse and see
1.71.
71 degrees. Is it less than 10 degrees?
Yes, sir.
So vessel is in compliance. Compliance with this requirement of intact stability regarding heel due to turning. Is that clear, beta? Guys, anybody has any doubts when to use tan theta formula, when to use this formula? That is the most important thing for you to figure out. Is it clear, class?
Yes, sir. Clear.
See, if it is clear and if you don't have any doubts, then I am done for the day. We have done two important things. And I have shared with you the questions on these two topics. Can you see if the questions have reached you?
Yes, sir.
Yes, sir. Received.
Okay. So we have done these two topics, inclining experiment, heel during turning. Tomorrow morning, we can connect at 9:30. I'll do 3-4 small topics again, depending on whatever pace we move it with. And whatever is left, I'll try and close out tomorrow evening so that by end of the day tomorrow, we are done with whatever we were committed. And then, of course, you'll have the support system in the group. Is that clear, beta?
Yes, sir.
Yes,
Okay.
sir.
Okay, guys, then last opportunity to clarify anything else. We meet tomorrow. Chalo then. Take care.
Thank you, sir.
Bye, guys.
Thank you,
Bye.
sir.
Take care. Take care. Take care. Bye.